Intel did not lose the chip war because it failed to understand computers. Intel lost because it understood one era of computing too well. For decades, Intel was not just a chip company, it was the company inside the computer. The name on the sticker, the architecture under Windows. The processor inside offices, schools, banks, airports, gaming PCs, workstations, and servers. The company that turned invisible silicon into one of the most recognized technology brands on Earth. Intel helped create the world where personal computers became normal. Then the world changed. Computing moved from desks to pockets, from general-purpose PCs to custom silicon. From CPU performance to power efficiency, from owning factories to using the best foundry. From what processor is inside your computer to how fast can your phone, cloud, GPU, and AI model work together. And Intel, the company that had once defined the center of computing, slowly found itself pushed away from the center, not by one rival. By a new map of the industry, Apple took control of its own chips. TSMC became the factory for the future. AMD used external manufacturing to attack Intel's strongest markets. Nvidia turned the GPUs into the engine of artificial intelligence. ARM became the architecture of mobile computing. And Intel, the company that had once made the rules, was left trying to catch up in a game it had helped make possible. That is the paradox. Intel created the chip war. Then it lost control of where the war was being fought. This is not a story about a dead company. Intel is still huge. It still sells billions of dollars of processors. It still owns deep engineering talent. It still matters to PCs, servers, manufacturing, national security, and the future of American chipmaking. But the old Intel is gone. The Intel that could assume the next computing era would run through its architecture. The Intel that could assume its factories would lead the world. The Intel that could assume customers would wait for it. The Intel that could assume performance meant x86 CPU performance. That Intel lost something more important than market share. It lost inevitability. For a long time, Intel's dominance looked almost natural. If you bought a serious computer, there was a good chance Intel was inside it. If a company bought thousands of office PCs, Intel was probably inside them. If a developer wrote software for the mainstream PC world, they were writing for the Intel-compatible universe, but none of this was natural. It was built, and the rise began with one of the most important accidents in technology history. In 1981, IBM launched the IBM PC. IBM was the trusted name in business computing. When IBM entered personal computers, the market took it seriously. Inside that machine was an Intel processor. Just as important, IBM's architecture became the template for the clone market. That choice helped turn Intel's x86 architecture into a standard, and standards are powerful. A better chip can win a benchmark. A standard can win an ecosystem. Software gets written for it. Hardware gets designed around it. Manufacturers build compatible machines. Customers buy what works with the software they already use. Developers support the platform because customers are there. Customers stay because developers are there. This is how a technical decision becomes a moat. Intel's early advantage was not only that it made processors. It became part of the default language of computing. Then, Microsoft Windows amplified that default. The PC became the machine of the office. Windows became the operating system. Intel-compatible processors became the engine underneath. Together, the world called it Wintel. This was not just a partnership. It was an ecosystem lock-in machine. Every new PC sale reinforced the standard. Every software release reinforced the standard. Every corporate IT department reinforced the standard. Every upgrade cycle reinforced the standard. Intel did not need to convince every customer to understand semiconductors. It needed customers to believe that a real PC had Intel inside. And then Intel did something brilliant. It made the chip visible. Before Intel Inside, most consumers did not care who made the processor. A chip was a component. Hidden, technical, invisible. Intel turned that invisible component into a brand. That was the genius of the campaign. It told customers to not only look at the computer brand, look at what powers it. Suddenly, Intel was not just a supplier to Dell, Compaq, IBM, HP, or Gateway. Intel was a consumer brand living inside other companies' products. That changed power. PC makers needed Intel. Because customers recognized Intel, retailers talked about Intel. Advertisements carried Intel. The little sticker became a symbol of performance, reliability, and modernity. Intel had done something rare. It made the inside matter to the outside. And that brand rested on a real technical machine. For years, Intel combined chip design and chip manufacturing better than almost anyone. It did not just design processors and send them to someone else. It owned the factories. It controlled process technology. It could coordinate architecture, manufacturing, packaging, performance, and production volume inside one company. This was the integrated device manufacturer model. And for a long time, it was Intel's superpower. Intel could spend huge amounts on fabrication plants because its PC and server chips produced high margins. Those margins funded the next process node. The next process node produced better chips. Better chips protected margins. Higher margins funded even more manufacturing leadership. It was a flywheel. Design leadership fed manufacturing leadership. Manufacturing leadership fed product leadership. Product leadership fed brand power. Brand power fed pricing power. Pricing power funded the next generation. This is why Intel's rise was not hype. Intel was genuinely excellent. Its factories were legendary. Its process technology was respected. Its execution rhythm became famous. The company helped make Moore's Law feel less like an observation and more like a schedule. Smaller, faster, cheaper, more powerful, again and again. This was the world Intel mastered. A world where the PC was the center. A world where performance mattered most. A world where software compatibility protected x86. A world where owning fabs was an advantage. A world where customers waited for the next Intel generation. But inside this success was the weakness. Intel's business was optimized for the economics of the PC era. High-performance processors, high margins. Control of the platform, a familiar architecture. Expensive factories justified by enormous volume. A customer base willing to pay for speed and compatibility. That system was beautiful. But it assumed the future would keep looking enough like the past. Then the future moved into the phone. The smartphone did not look like Intel's core business. It was smaller, cheaper, lower power, more integrated, more dependent on battery life, more focused on system-on-chip design than raw CPU dominance, more influenced by wireless, sensors, cameras, graphics, and power management. The phone was not just a tiny PC. That was the trap. For Intel, it was tempting to see mobile as another market that would eventually need Intel-class performance, but mobile did not reward the same things. In a desktop PC, power consumption matters. In a phone, power consumption is destiny. In a PC, the CPU can be the star. In a phone, the whole system matters. In a PC, compatibility with decades of software is a moat. In mobile, old compatibility is less important than battery life, integration, and control. ARM-based chips were built for that world. They were not trying to beat Intel at Intel's old game. They were playing a different game. This is how disruption works at its most dangerous. It does not start by looking superior to the incumbent. It starts by looking too small, too cheap, too limited, or too low margin to matter. Intel had mobile efforts. It was not blind in the simple cartoon version of the story. It had low-power processors. It had Atom. It had communications assets. It tried to win phones and tablets. But the company's center of gravity was still the PC and server world. That mattered, because organizations do not only make decisions with strategy documents. They make decisions through incentives. Intel's best customers were PC makers and server buyers. Its best margins came from high-performance x86 processors. Its identity was tied to process leadership. Its software ecosystem was tied to compatibility. Its internal machine rewarded the world it already dominated. So when mobile rose, Intel faced a hard question. Should it attack the future on the future's terms, even if those terms were worse for Intel's existing business? That is the question incumbents hate. Because the right answer often means weakening your own moat before someone else does. Intel had once owned ARM-based X-scale assets. In 2006, it sold its communications and application processor business to Marvell. At the time, this could be defended as focus. Intel wanted to concentrate on its core strengths, but history is cruel to focus. The market Intel moved away from became the market that defined the next computing era. Then came the iPhone. The iPhone was not just a new device. It was a new center of gravity. The PC had been the default personal computer. The smartphone became the new personal computer for billions of people. That shift changed the chip industry. The most important device in daily life was no longer built around Intel. The fastest-growing computing platform was no longer x86. The most important operating systems in consumer technology did not depend on Intel's roadmap. For Intel, this was not one lost customer. It was a lost architecture transition, and mobile did something even more damaging. It made custom silicon normal. Apple did not want to be just another company waiting for a supplier's chip roadmap. It wanted control over the whole experience. Hardware, software, battery life, performance, camera, security, machine learning, and design. That meant custom chips. At first, Apple's chip strategy mattered mainly in phones and tablets, but the logic was bigger. If Apple could design better chips for its own products, why should Macs depend on Intel forever? In 2020, Apple announced the transition of Mac computers from Intel processors to Apple Silicon. That moment was symbolic. The company that had once adopted Intel to make the Mac more competitive now left Intel to make the Mac more efficient, more integrated, and more controlled. Apple's message was not only we can design chips. It was, the old Intel roadmap no longer defines our future, and the market noticed. Apple Silicon showed what the new chip world looked like. The advantage was not just one CPU core. It was the whole system. CPU, GPU, neural engine, memory architecture, power efficiency, software optimization, and manufacturing through TSMC. This was Intel's nightmare in product form. A major customer using a non-x86 architecture, designed in-house, manufactured by the foundry that had surpassed Intel in advanced node execution, delivering performance and battery life that made the old PC assumptions feel outdated. Intel had lost the mobile revolution. Then mobile's logic invaded the laptop. But mobile was only one front. The second front was manufacturing. For decades, Intel's factories were its crown jewel. Owning fabs gave Intel control. It could tune designs to its process. It could protect secrets. It could lead the industry's manufacturing cadence. Competitors who did not own comparable fabs had to rely on outside foundries. That used to look like weakness. Then TSMC turned it into strength. TSMC's model was different. It did not compete with its customers in end products. It did not design CPUs to sell against Apple, AMD, Nvidia, or Qualcomm. It focused on being the neutral manufacturing partner for the world's best chip designers. That neutrality became powerful. A company like Apple could design its own chips and use TSMC. A company like AMD could design CPUs and use TSMC. A company like Nvidia could design GPUs and use TSMC. A startup could design an accelerator and use TSMC. TSMC became the factory behind other people's ambitions. And because so many customers depended on it, TSMC could learn from enormous scale across smartphones, GPUs, CPUs, AI accelerators, networking chips, and custom silicon. This changed the industry. Intel's old model said, "The best chip company designs and manufactures its own chips." The new model said, "The best designers can use the best manufacturer." That separation was devastating for Intel once Intel's manufacturing execution stumbled. And it did stumble. The 1.5-nanometer delay became one of the key red flags in Intel's decline. For years, Intel had conditioned the industry to expect manufacturing leadership. But when its process roadmap began slipping, the entire promise weakened. A delay in semiconductor manufacturing is not like a delayed app update. It cascades. If the process node is late, the products are late. If the products are late, customers wait or move. If customers move, competitors gain share. If competitors gain share, developers, investors, and buyers start to believe the momentum has shifted. And once momentum shifts in semiconductors, it is extremely hard to reverse. Intel's 14-nanometer generation lasted too long. Its 10-nanometer struggles became a symbol. Its 7-nanometer delay raised more questions. Meanwhile, TSMC kept executing for customers that were attacking Intel from every side. AMD was the clearest example. For years, AMD had lived in Intel's shadow. It was the challenger, often interesting, sometimes dangerous, but rarely the company that defined the market. Intel had the manufacturing edge, the brand, the OEM relationships, and the data center position. But AMD changed its strategy. It focused on architecture. It embraced chiplets. It used TSMC manufacturing. It let the best foundry help it compete against Intel's old integrated machine. This was not just AMD getting better. It was the industry structure turning against Intel. AMD did not need to own better fabs than Intel. It needed access to TSMC, strong designs, and a product strategy that used modularity to scale. That was enough to challenge Intel in PCs and servers. The server market was especially painful. Intel had long dominated data center CPUs. Cloud providers, enterprises, and hyperscalers depended on Xeon. That business was high margin and strategically central. It was exactly the kind of market Intel was supposed to protect. But AMD's EPYC processors gave customers a serious alternative. More cores, strong performance, competitive efficiency, a credible roadmap, and behind it, TSMC manufacturing. Suddenly, Intel's customers had leverage. That was new. When customers have no serious alternative, they tolerate delays. When customers have alternatives, they compare. And they did. The third front was AI. This may be the most painful part of the story, because AI made the center of computing move again. Intel had built the era where the CPU was the king. But AI elevated the GPU and accelerator. Training large models was not mainly about the classic PC CPU. It was about massive parallel computation, memory bandwidth, software ecosystems, networking, and full-stack acceleration. That was Nvidia's world. Nvidia had spent years building not just GPUs but CUDA, developer tools, libraries, data center systems, and a belief that accelerated computing was the future. For a long time, that looked narrower than Intel's empire. Gaming GPUs, workstations, parallel computing, niche high-performance workloads. Then deep learning turned the niche into the center. The same pattern repeated. A market that did not look like Intel's core business became the next center of computing. Nvidia did not beat Intel by becoming a better x86 CPU company. It beat Intel by making the CPU less central to the most important new workload. That is what made the AI boom so brutal for Intel. the company that had powered the PC revolution, was not the default engine of the AI revolution. In the new data center, the question was not only which CPU, it became which GPU, which accelerator, which networking stack, which software ecosystem, which foundry can build the most advanced chip, which system can train and run the model. Intel still had CPUs in the data center, but the value migrated upward and outward. Nvidia captured the excitement. TSMC captured the manufacturing demand. Cloud companies started designing custom chips. AMD attacked with CPUs and GPUs. Apple showed custom silicon in consumer devices. ARM expanded beyond mobile. Intel was still important. But the story of the future no longer revolved around it. That is the real fall. Intel did not go from success to irrelevance. It went from being the center of the map to being one player on a map drawn by others. The red flags had been visible for years. The missed mobile wave, the sale of mobile processor assets, the dependence on PC economics, the delays in process technology, the loss of Apple, the AMD comeback, the rise of TSMC, the Nvidia AI boom, the pressure to build a foundry business from behind, the financial strain of trying to restore manufacturing leadership while defending existing product markets. But each red flag could be explained in the moment. Mobile margins were low. The PC was still profitable. Servers were still strong. Manufacturing delays were fixable. Apple was only one customer. AMD had risen before and fallen before. Nvidia was not a CPU company. TSMC was just a foundry. Intel had survived transitions before. That is why the story continued. This is how great companies miss turns. Not because the warning signs are invisible, but because the old model still produces enough success to make the warnings feel manageable. Intel's old business kept working long after the future had started moving away. PCs still sold. Servers still needed CPUs. Enterprises still trusted Intel. OEMs still built around Intel. The brand still mattered. The factories still existed. The company still generated enormous revenue, but the direction of advantage was changing. The industry was moving toward specialization, foundry scale, power efficiency, custom silicon, accelerators, and software-defined hardware ecosystems. Intel was still built around the assumption that its own x86 roadmap and manufacturing process would define the mainstream. That assumption had once been reasonable. Then it became expensive. The moment of truth was not one single event. It was a chain. Apple leaving Intel showed that even premium laptops did not have to depend on x86 Intel chips. AMD gaining ground showed that Intel's CPU dominance could be attacked when manufacturing advantage disappeared. TSMC's rise showed that the world's most advanced chips did not need to come from Intel fabs. Nvidia's AI explosion showed that the most valuable computing workloads could be centered on accelerators, not CPUs. Intel's foundry push showed that the company itself understood the old model was no longer enough. And that is the hardest part. Intel did not deny forever. It tried to change. Pat Gelsinger returned with an ambitious plan to restore process leadership and turn Intel into a major foundry. The idea was bold: rebuild Intel's manufacturing edge, open the fabs to external customers, compete with TSMC and Samsung, and make Intel central to Western semiconductor strategy. This made strategic sense. The world had become nervous about depending so heavily on Taiwan for leading-edge manufacturing. Governments wanted more geographic resilience. The United States wanted advanced manufacturing capacity at home. Intel had fabs, history, talent, and political importance. But knowing the answer is not the same as executing it, foundry is not just manufacturing. It is service, it is trust. It is customer neutrality. It is design tools. It is predictable execution. It is a culture where outside customers believe their roadmap is safe inside your factory. That is difficult for a company that spent decades manufacturing mainly for itself. Intel had to become something it had never fully been, a trusted manufacturer for companies that might not use Intel designs. That is a deep cultural transition. TSMC was built for that model. Intel had to retrofit itself into it while also fixing products, cutting costs, protecting existing businesses, and catching up in process technology. That is why the turnaround became so difficult. Intel was not only trying to regain leadership, it was trying to rebuild the machine while the industry kept moving. In 2025, leadership changed again. Lip Bhutan became CEO. The message shifted toward discipline, engineering focus, customer trust, and a more realistic foundry strategy. That tells you how serious the crisis had become. Intel did not need a normal strategy update. It needed institutional repair. Because the fall of Intel was not caused by one bad product or one missed deal. It was a system problem. The company had optimized around the belief that control was strength, control the architecture, control the fabs, control the roadmap, control the brand, control the PC ecosystem. In the PC era, that worked. But the next era rewarded different strengths. Apple controlled the product experience, but used TSMC manufacturing. AMD controlled design focus, but used external fabs. Nvidia controlled the accelerator ecosystem, but used TSMC's process leadership. TSMC controlled manufacturing, but did not compete with its customers. Cloud companies controlled workloads and began designing custom chips for themselves. Control did not disappear. It moved to different layers. Intel had controlled the old layer. The industry's value moved around it. This is the key mechanism of Intel's decline. The company's strength was vertically integrated dominance over general-purpose computing. The market shifted towards specialized computing built through horizontal ecosystems. Intel's old moat did not vanish overnight. It became less decisive. And when a moat becomes less decisive, the company inside it can mistake walls for protection even as the battlefield moves somewhere else. The human price of this story is not only shareholders losing money or executives losing jobs. It is also industrial. Intel was one of the symbols of Silicon Valley manufacturing excellence. It represented a version of technology where the United States did not only design the future, it fabricated it. When Intel stumbled, it created a national anxiety. Who builds the most advanced chips? Where are they made? Who controls the supply chain? Can America still lead in semiconductor manufacturing? Can a company that lost process leadership regain it in time? These are not abstract questions. Chips are inside everything. Phones, cars, data centers, satellites, defense systems, medical devices, power grids, and AI infrastructure. Intel's decline became bigger than Intel because semiconductors became bigger than consumer electronics. They became economic power, military power, industrial power, AI power. That is why governments cared. That is why investors watched. That is why Intel's foundry plan mattered even to people who never buy Intel stock. The world needs more than one leading-edge manufacturing option. But need does not create competitiveness by itself. Intel still has to earn customers. That is the cruel part. A country can want Intel to succeed. Airlines, banks, cloud providers, and PC makers can want supply chain diversity. Governments can offer support. Executives can announce roadmaps. But customers do not build chips on patriotism. They build on yield, cost, performance, power, packaging, tools, trust, and delivery. That is the standard Intel must meet, not the standard of its past. The standard of the new industry. And that new industry is unforgiving. If Apple can get better performance per watt from its own chip, it will use its own chip. If AMD can get better server economics through TSMC, customers will consider AMD. If Nvidia can deliver the best AI platform, cloud companies will pay Nvidia. If TSMC can execute advanced nodes reliably, designers will stay with TSMC. If hyperscalers can design custom accelerators for their own workloads, they will not wait for Intel's idea of the future. The old Intel could depend on the world needing its roadmap. The new Intel has to compete for relevance inside other people's roadmaps. That is a much harder position. But this story should not end with the lazy conclusion that Intel was stupid. Intel was not stupid. Intel was trapped by a successful model. The PCE era taught Intel that x86 compatibility was power. It taught Intel that owning fabs was power. It taught Intel that premium CPU performance was power. It taught Intel that customers would follow its cadence. It taught Intel that the inside of the computer could define the outside experience. Those lessons were true until they were incomplete. The smartphone era said, power efficiency and integration can beat legacy compatibility. The foundry era said, the best manufacturing can serve many designers, not just one. The AI era said, the most valuable compute may not be centered on the CPU. The custom silicon era said, the biggest customers may want chips built exactly for their own workloads. Intel's tragedy is that it did not lose because its old beliefs were nonsense. It lost because they had once been correct. That is what makes great company decline so dangerous. The habits that created dominance become the habits that delay adaptation. The same confidence that lets a company invest billions in fabs can make it slow to accept that someone else's fab is better. The same architecture that created software lock-in can make a company underestimate new platforms. The same margins that fund innovation can make low-margin new markets look unattractive. The same brand that once signaled leadership can hide the moment when leadership has moved. Intel Inside was once a promise. It told the world, the most important part of your computer is here, but the meaning of inside changed. Inside the phone was ARM. Inside the iPhone was Apple Silicon. Inside the AI boom was Nvidia. Inside the leading-edge chips was TSMC manufacturing. Inside AMD's comeback was a foundry model Intel had not mastered. Inside the new cloud was custom hardware built for specific workloads. Intel was still inside many machines, but it was no longer inside the main story. That is how Intel lost the chip war it created, not in one battle, but by winning the old war so completely that it struggled to see the new one. The final lesson is not that integration is bad. Integration made Intel great. The lesson is that every business model has an expiration date if the world around it changes enough. A moat protects you only if the enemy still wants to attack the castle. For years, Intel built the strongest castle in personal computing. Then, computing stopped being only personal computers. It became phones, cloud platforms, GPUs, AI accelerators, custom chips, foundries, software ecosystems, and supply chain strategy. The war moved. Intel is still trying to move with it. Maybe it can rebuild. Maybe its foundry strategy will work. Maybe future process nodes will restore credibility. Maybe x86 will remain stronger than the market expects. Maybe Intel becomes essential again because the world needs manufacturing diversity. But the old inevitability is gone. Intel now has to prove what it once could assume. That its factories can lead, that its products can win, that its roadmap can be trusted, that its culture can execute, that its place in the future is earned, not inherited. For a company that once taught the world to ask what was inside the computer, the question has turned back on Intel itself. What is inside Intel now? A lost giant defending the past? Or an institution disciplined enough to rebuild for a world it no longer controls? That answer will decide whether Intel's fall becomes a permanent decline or the painful beginning of a second act. But either way, the old story is over. Intel created the PC age by making the processor the center of computing. Then computing escaped the center. And the company that once lived inside every computer discovered that the future had learned how to run without it.